We're now on to question 5, and this is a 5-mark question. Let's start off by rewriting the left-hand side. So we have left-hand side is equal to cos 3x over cos x. Now the numerator, cos 3x, that is, we can actually compound that. So we can rewrite that as cos x plus 2x. Let's go ahead and do that. And now what you now notice is that since we've compounded it, x represents a and 2x represents b. So what we actually have here is cos a plus b. And remember your expansion for that is cos a cos b minus sine a sine b. So I'm going to expand it accordingly. So here's our expansion. We have cos x cos 2x minus sine x sine 2x. Now what we notice is that we've got these double angles for cos and sine. Now the tricky one here is expanding cos 2x. But remember, the trick that we use is that we look at the right-hand side, the answer that we need. And if you look at this answer, it only has cos in it, which means that the expansion that we choose for cos 2x should have only cos in it and not sine. So the expansion that I'm going to choose is 2 cos squared x minus 1. Now when I expand sine 2x, there is only one expansion, that is 2 sine x cos x. There we have it. At this point in time, we realize that our numerator has something common. Both terms contain cos x. And if we factor out that cos x, it can cancel out with the cos x from the denominator. So let's go ahead and do that. So when we pull out cos x as a common factor, what we're left with is 2 cos squared x minus 1. And then from our second term, we can multiply negative sine x with 2 sine x to get negative 2 sine squared x. And now the cos x from the top and bottom cancel out with each other. Now, seeing that the answer that we need has cos in it and not sine, we need to find a way to get rid of the sine squared x here. So we're going to make use of our identity. So remember your identity, sine squared x plus cos squared x equals 1. Let's make sine squared x the subject. We can do that by taking cos squared x over to the right-hand side. So we have sine squared x is equal to 1 minus cos squared x. That is what we're going to replace sine squared x with here. So there we have it. I've replaced sine squared x with 1 minus cos squared x. Now to simplify, we're going to take this negative 2 and multiply it into the bracket with both terms. Doing so, we have negative 2 times 1, which gives you negative 2. Negative 2 times negative cos squared x would be positive cos squared x. Now we're going to gather like terms. We've got 2 cos squared x plus 2 cos squared x. That is going to be 4 cos squared x. We have minus 1 minus 2, which is minus 3. And we notice that, hey, that gives us the right-hand side. They had 4 cos squared x minus 3, and we have that too. So that is equal to the right-hand side. So here's where your 5 marks were given. You had 1 mark allocated to expanding the compound angle, 1 mark each for the double angles for the cos 2x and the sine 2x, 1 mark for applying the identity where you had sine squared x and replacing it with 1 minus cos squared x, and the 5th mark was given where you took that negative 2 and you multiplied it into the bracket, so where you expanded this whole thing. And that is your 5 marks. Please remember to like, subscribe, and turn on your notifications for more content.